Good day guys, being here. Today I'm going to redo this exercise, so day 73, and also we're going to make it fully parametric. Okay, so we can change the profile. And okay, so let's do it. So this is roughly it will be. You can change the profile, and okay, you can change the thickness, and also of course you can change your height, and you can change the thickness of the panel as well. Okay, so let's do it. So okay, so first let's create a generic model and place some reference plans, or RP. So first let's draw two horizontal reference plans, and we need 4 vertical reference plane. Okay, so now dimension equal and equal. So again, 1, 2, 3 equal, and then we need a parameter 4. So this is the thickness of that profile, and this will be the length of the profile. Okay, so this one. So let's create, maybe let's call it X, and instance. Okay, and this one will be Y. I think a type and inst. Yeah, it should be the same. But anyway, let's just use instance. So, oh hell. So both lowercase. That's fine. So now I'm going to just draw. Let me just do a screenshot of this. So this is X. So the profile will be something like this. Okay, and then it will be three arc. So 1, 2, and 3. So now if I connect, so this one, so I'm not sure where the center of this arc is. Maybe it's here. So if I connect this one to here, connect this one to here, and from this X, this is X. Okay, so this is Y. So from this we know that this one is X divided by 2, and this one is Y divided by 4. So this is a right angle triangle. And then, so what we need to work out is the radius, so which is this one and also this one. Okay, and so to work out this one, I think we need to, so we can do this. So if I connect these 2 points and connect this to the middle of this, because this equals this and both are the radius. So let's call, I'll just write here. So this is a radius and this is a radius. So this will be the right angle, and we can work out the R from this triangular shape. So what we need is we need one angle. So this one, because this angle equals this one. Okay, so this in this triangular shape we can work out this angle by using arctangent of these 2 edges. So we know this one, and then another one is this edge. So this edge is half of this, and we can work out this one from this triangular shape as well. Okay, so now let's just write some formula. So to work out R, so if I call this angle A, And if I call maybe we work out this one first. Okay, so what do I call this? Maybe let's say x, y, maybe call it z. Okay, so if we call this from here to here, so call from here to here, if we call this one z equals square root of x divided by 2 square plus y divided by 4 square, right? And then half of this z, so which is this part, so it's divided by 2, and then it will be divided by 2. Okay, so also now we need to work out the angle. So in this triangular shape, so this is A as well, so tangent A equals this one, y divided by 4 divided by x divided by 2. So which means angle A equals arc tangent this one. Okay, so this one. So now we know A, and in this triangular shape we will use cosine. Okay, so cosine A equals this one, so which is this one, go up here. Cosine divided by the radius. Okay, the radius, which means so if I swap this r with the cosine A, r equals, so this one, still this one, go to here, divide by cosine A, so cosine, and A, so we can do a bracket, A equals arc tangent, so it's cosine bracket arc tangent that, so y divided by 4 divided by half of x, so this is the formula R. Okay, so now let's go back to Revit. So now we can create let's do a model line. So we will use the start and radius, so just start from here and to here. So roughly I'll just place it like this, okay, and then select this. So we need to check the center mark visible, and then so we can align this and lock onto this center reference plane, and then we will need another reference plane here and to lock this, so AL, and lock this, and then we need a dimension from this center reference plane to this, and this equals, so if you look at here, so hang on, so from here to here looks like it should be from, oh sorry, this one's wrong, it needs to be from here to here, and then so this will be R. So let me just select this one and create this radius and create a radius parameter, let's call it R instance, and OK. So this one is radius as well, so I'll just link this to R, and now you will see it's not because we haven't put the formula in R, the radius yet, so you will see this stop here. So now we can go to family types, and let me just drag this onto my next screen so I can just copy the formula. So R equals sqrt square root of bracket, another bracket, x divided by 2 bracket square plus bracket y divided by 4 bracket square and bracket divided by 2 and bracket. We will need another bracket at the front, and then divide by cosine bracket arctangent bracket arctangent bracket and another bracket y divided by 4 bracket and divide by bracket x divided by 2 bracket. I think we need another bracket. So yes, great. So now if I click apply, and you will see this arc will match that, will go finish at here exactly. Okay, so this is a formula. So it's exactly this one. So R equals this divided by this. Okay, so now let's click OK, and then this is the first part, the middle part, and then we need another 2. So the other 2 part, well actually, so it looks like they are very close. Maybe I'll change the x a little bit, so it will, it will separate them. So now this is a very flat profile, so R becomes bigger, so it will go there, but still it will start from this point to this point, and the middle point will be here. So now let's create another model line here. So it will be start from if you draw, let's try to do this. So you can draw an arc, so just a model line, so like this, and then even if you don't add a radius, you can use a toggle join tangency. So, and then if you try to change it, you will see it will always tangent to these two arcs will always be tangent. So if I try this, so change this x, you will see this arc will change as well. But this is okay, but sometimes it will break. Okay, so it's always better to lock it properly. So what I'm going to do is I'll just use arc, create another radius, and I'll first align this to this vertical. Oh hell, let me just check the center mark, and we can align and lock. And then we also need another reference plane here. So this one will be the same, so from here to here, and this will be the R as well. So and then AL lock and lock. So and then maybe even this end you can always oh, it's already locked, so that's fine. So yeah, I think that's it's safer to do it this way. So let's create another one. So model line. So you can first just do a arc like this, and then select it, create a. Don't worry about that thing. So because once you lock it properly, you don't need to worry about that. So center mark visible, AL, lock it here, and then use this one, and that's it. So now let's have a test. So I'll change this scale. So if I change x to 100, okay, something's not right. What's going on here? Let me have a. wait, 500, 100 maybe. What's going on? Maybe because of the tangency. So let's just change them back to that R again. Okay, let's try again. Okay, so 200. Yeah, it's working now. I think it's probably the extra constraint. So sometimes if there's too much constraint, so you will have issue. So looks like all good now. Yep, all good. So you can even try this. Oh, looks like it doesn't work this way. Maybe we need to lock this. No, still not this one. Maybe the R. No. Anyway, it's good. Just let's use this one. Okay, so now we have model line, which is all good. It's parametric, and then we can. The easiest way is to just use sweep. Okay, so I'll just pick part 1, 2, 3, and finish. And let's go to 3D view. So we can just create a profile. So select profile, edit profile. So I'm going to just draw a profile like this. Okay, and I'll lock this edge onto this reference plane, and then I'll just do a dimension. So 1, 2, 3, because I want it to be centered. So equal, and we need another dimension. So from this to this, and this will be the thickness. So let me change the scale. So this is the thickness of this panel, of the metal, not the overall thickness, but the thickness of the metal. So we can select this dimension and create a thickness. I'll just call it th1 maybe. So instant, or maybe type. Yeah, type, okay. And then that's it, and then select this one. We can just add a dimension. So this one, so from here to here. So this will be the height of the panel. So let's just call it H. Maybe instance. Okay, so okay, and okay, so now we can finish this sweep. Finish. So now this is it. Okay. And then we can, let's just have a test. So for example, thickness 2 mil, so very thin. 50, so very flat. So change this to 200. Yeah, all good. And height 1200. Apply. That's it. So now this is it. This is individual one profile, and then we can load this into a new. Let's create a maybe let's use line-based generic model. Okay, so load this into here. So I'll just place it roughly here. Okay, so now I'm going to lock this AL. I'm going to lock this, so I'll use this edge. Okay, so lock, and also I'm going to do an array AR. So select here, roughly here, and finish it. So now create a reference plane RP and do dimension, and let's call this what do we call it? Let's call it Y, because we use Y for that one. So we'll use Y. Okay. Y will be instance. Yeah, instance is fine. And okay. So now I'm going to tab select this family, and hang on, we can't because they are instance parameter. So we need to edit group. Let's have a look. Yeah, in the group we need to link the Y, or link Y, this Y to this Y. constraint not satisfied. What's going on here? Okay, so it looks like we can't lock onto the model. That's fine, I'll just leave it. So X will create a new X, and I'll create a height. So I think that's it, and then I'll finish it. Okay, and then we can lock it. Let's lock it again. So lock it, lock, and then this is the second one. So let's lock this onto this reference plane and lock. So now select one of this group, and then click on this array and create a parameter. So let's call it a number and instance, and OK. So now we go to family types. Okay, so the number, we need a formula. So what we're going to do is use length divided by y. Okay, so type in length divided by y, apply. So now we have this array, and you will see this, it will be longer than this reference plane. Maybe we can just use a -1, apply. Okay, so now let's try this one. So if you drag this, you will see it will increase the number, but you will see when I there should be another one here. So which means we need to use round up. Okay, so round up, bracket, length divided by y, bracket, -1. So apply. Okay. Oh, hang on. Maybe we can do this. Maybe we can round down. Let's try round down. Okay, so round down, length divided by y. Apply. Should be the same. Yep, that's correct. So you will see, as soon as this reference plane touch that profile, it will reduce 1. That's great. So yeah, I think that's it. Let's try. Let's see if we can. So if we change x, okay, so 40, we're good. 20, yes. 100, good. 50. Okay, y. Let's try 200. Yes. 300. Good. So yeah, 200, and height should be okay. Should be all good. All good. So let's have a look of the height. And 1500. Yep. So that's it. So this is the corrugated panel, line-based family. So it's a fully parametric. So let me just create a project, and so we can load this into the project. Okay, so so maybe I'll just draw a floor, and I'll load this onto the floor. So because it's a line based, you can place on face if you want to. And let's try if I add a slope to it. Yeah. So and because it's line based, you can split. Okay. And also, and you can even trim them, or and then and if I change the height, oh good. If I change the thickness, profile thickness, oh good. If I change the profile length, and where's my thickness? Let's have a look. I think should be somewhere, or maybe yeah, because I created as a type parameter, so that's fine. I'll just call it th. Okay, so and instance or type. Let's just still use type. And okay, and then I'll load this into the project. Okay, override, and then select it, and then edit type. So yeah, so you can change the thickness of the metal, so you can see. And that's it. If you have any question, please let me know. Do you? I'll upload this family, so if you want to have a look. Okay, so that's it for today. Thank you very much, and I'll see you next time. Bye.